right, section 3.2, adding integers. You guys are going to think this is a really stupid section because it's very basic, very, you can do it with your calculator, but I prefer that you don't use your calculator on this assignment. So we talked about what an integer was, and we're just referring to them as whole numbers and their opposites. So any two integers that are on either side of zero on a number line and equal distance from it are considered opposite integers, like 3 and -3 are opposites. They're also called additive inverses because when you add them up, you get zero when you add them. So this is the part we're talking about, adding and subtracting integers in this lesson. And there's two rules that you need to remember. Rule A, if the numbers have the same sign, then add the numbers together and put down the sign of the larger one. So, put down the sign that's there. So if we have two positive numbers together, we're going to put down the positive, but do we really need to put down the positive when there's two positives? No. So if we have two negatives that we're adding together, we're going to forget that they're negative. We're just going to add them together as regular integers, and then we're going to put the negative sign down as the final answer. And then the second rule is if you have opposite signs, you're going to take the smaller one from the larger, so larger minus smaller, and you're going to use the sign from the larger number. So let's just look at these three examples here. This is a +7 and a +3, so therefore they're the same sign. We add them together, we get 10. 6 minus 7, they're opposite signs because this is considered a 6. And this, we're going to treat this subtraction as the sign with the 7. We're going to think of those two things not as a operation, but as a sign. So +6 and -7. 7 minus 6 is 1, and the sign from the larger is negative. 4 plus a -3, it's just another way of writing 4 minus 3, but 4 is the larger one. That's the positive. 3 is a smaller one, so 4 minus 3 is 1. The sign from the larger is positive, so we don't have to put it down there. Now, I put these examples here because I want you to see how these two relate to each other. So a +7 minus a -3. That minus a -3, those two negative signs right together make a positive number. So we take the operation and the sign, put them together, and it makes a positive. So we end up with 10 as our answer. So those two are basically the same problem, just like these two are the same problem. 6 plus a -7 is the same as 6 minus 7. -7 is the larger one. 6, you take 6 from it, you get 1. The sign on the larger one is negative. And then 4 minus 3, we know that to be 1. And like I said, this seems very simple, very basic, but adding and subtracting numbers, just plain integers, are a problem for some students. And the problem comes in when we look at this one and this one, realizing that sign or that operation here is really just the sign of that negative. And that's because subtraction is the same as adding the opposite. So this subtraction sign right here is the same as adding the opposite of 7, which is -7. And we use that, and we want to get to the point where we recognize that there's not a difference between the operation and the sign. that we're talking about. Now, as we've said before, the book presents this information in multiple ways, and they want to make sure that if you're a visual learner, that you can have a way of adding and subtracting these numbers without, I'm going to say without thinking about it too much, but that's probably not the correct way to say it. So here I have 7 plus 3. I'm always going to start my graphs at 0 and move in whichever direction that first number is. So the first number is positive, so I'm going to go to the right 7 units. And then from there, I'm going to go to the right 3 more units. So I have to go out here 3 more units, and that is the 7 plus 3. And that puts us at 10. So the book makes a real big deal about this. So I just want to make sure that when you go to your assignment, if they ask you to do these problems, you know how to do it. So start at 0, go to the right 6. We have a subtraction, so we're going to go to the left 7 units. And we end up at -1. That's our final. And then the last one would be very similar to that one right up above. We go to the right 4 units. And then from there, we go to the left 3 units. Now, how do you do a 7 minus a -3? This looks exactly the same way as the top one. So 7 units to the right. We're subtracting, so we would be going back this way, but we're subtracting the opposite of 3, so we're actually adding 3 on. And we show it as that to get to the 10. So if you have more than 2 numbers that you're adding together, it doesn't matter which order you add the numbers, as long as you keep the sign that's in front of the number with the number. So in all of these cases here, I have the operation sign, and then I have the sign of the number, operation number. I could very easily write this as, as 2 plus 15 minus 2. That could be another way to write that equation, and just eliminate that plus sign and take the plus the -2 and make it a subtraction. Doesn't matter which way you do it. What you're going to be interested in doing is keeping the signs together. So we can just go through and add this 2 plus 15 and get 17, and then add a -2 and get back to 15. That's normally the way we would do it. If you're doing it in your head, you might see that this +2 and this -2 cancel each other out to be 0. And so the only number you're left with is 15. Same thing over here. You might want to do this addition and subtraction first, because that goes down to 0 and you're left with -14. We could combine these two because they're like signs and say a -14 plus a -6 is a -20. Then we have -20 plus 6, which gives us that -14. So it doesn't matter which order you add those things in, and that is because there's a property that we'll talk about later on called the commutative property, and with the commutative property of addition, you can switch things around. And of course, we can't leave a section without having a story problem. So the temperature is -3 degrees. An hour later, it drops 6 degrees. And 2 hours after that, it rises 4 degrees. write an expression to describe this situation. Well, first thing, we're going to go back and look at what we have. So the temperature is -3. So that's where we're starting our problem at, -3. An hour later, it drops 6 degrees. So that drop would represent a negative number. So we're going to drop 6 degrees. I can put a plus sign there and the 6 degrees in parentheses, or I can just write it as 3 minus 6. 2 hours later, it rises 4 degrees. So I can add that 4 onto the end. So that is our addition expression. And now we're going to find the sum and then give a meaning to it. So -3 plus a -6, that's a -9. And then we're going to add 4 to that, and we're going to end up at -5. And in either case, we would end up at -5. So what does that mean? The temperature is 5 degrees below 0. Or we can say the temperature is at -5 degrees. Either way. So that's the section. Like I said, I'd like you to do it without a calculator just to get used to adding and subtracting positive and negative numbers and get comfortable with that. But that's all there is to section 3.2.
And it doesn't let us do negative numbers on our calculator anyway, I don't think. So.
Yeah, there's a little negative sign that's in parentheses. I think one of your buttons is it's an opposite sign is what it is.